All right, so inequalities for the exam. Inequalities are things that don't have an equal sign, but they have some sort of relationship still described. So most often we see something like this. This is x is greater than 4. You can also have x is greater than or equal to 4, x is less than 4, or x is less than or equal to 4. So there's basically 3 pieces to these inequalities. One piece is solving them. So we're going to start with solving an inequality. So solving inequalities is much like solving an equation. So this is what we went over in class. In class, we started with something a little basic. We said, okay, well, we know 1 is less than 3. You can write this relationship. And then you can always remember the kid version of how to keep this straight is this is like the alligator and it eats the bigger number or whatever. But if we have something like 1 is less than 3, if we add 2 to both sides, we still have a true statement. 3 is still less than 5. And this makes sense when you think about the number line here. We started with 1 being less than 3. So 1 was left to the left of 3 on the number line. Adding 2, all that does is take both of our points and move them up 2. So the 3 is still less than 5. All we've done is shifted the number line over. So this makes sense. Subtraction also works the same way. So if we have our 1 is less than 3 and we say subtract 1 from both sides, we're still going to have a true statement. 0 is less than 2. And this version, we're taking those 2 dots and we're just moving them 1 to the left. So what was on the left is still on the left. So this gives us the addition and subtraction principle of inequalities. Or rule, principle, I don't care. Basically tells us if we have something like A is less than B, then A plus C is less than B plus C. So we can add the same thing to both sides, and we don't change the inequality, much like if we had an equality or an equation. Okay, so what about multiplication and division? That's where things get a little bit trickier. We start with less than 1 is less than 3 again. We multiply by 2 on both sides, much like doubling up our money at a roulette table. We still have a true statement. 2 is still less than 6. Right? We've taken and stretched our number line, essentially, taken those points and stretched them. But if we start with 1 is less than 3 and we multiply 3 by a negative 2 on both sides, well, then we get negative 2 is less than negative 6. And that is not a true statement. Think back to our number line here. 1, 2, 3, 4, 5, 6. This is negative 6. This is negative 2. Negative 6 is less than negative 2 because it's to the left of negative 2. And that's not the way that this inequality is facing. So multiplication and division, when we talk about inequalities, they don't have the same rule. Their rule is, it's fine. If A is less than B, then CA is less than CB if C is a positive number, if C is greater than 0. So if we multiply by a positive, we're in this land and everything's A-okay. But if we multiply by a negative, or divide by a negative, because remember they're 2 sides of the same coin, then we must flip our inequality. So in this case, this would have been fine. We just need to flip around the inequality, because essentially what we're doing when we multiply by a negative is we're flipping the entire number line backwards. So what was positive over here, positive 2, being less than 6, it's flip-flopped when we change them to negatives, right? So got to flip our inequality as well. So that's it. If we want to try an example, I'll give you one, something like 3x plus 4 is less than 5x minus 7. No idea how that's going to work out. But take a moment and try that on your own. All right, if you've had a moment to try this on your own, you have 2 ways to solve this one. One way is that we could try to get our x isolated, our x terms, on the left side. So if we subtract 5x from both sides, we'll cancel the x's from the right side and leave ourselves with negative 2x. If we're doing that, we might as well go ahead and try to cancel out the constant on this side. So now we're here, and those canceled, and we have a negative 11. And then we get to this point, and we go, oh, we need to get rid of this negative 2. But this is where we just divided by a negative. This is where we need to flip our inequality. So we're going to cross this off, and we're going to go ahead and make that a greater than. And now we have x is greater than 11 over 2. So one thing to keep in mind here is it's only multiplication division by a negative. That's the only time. And if you're not sure and you want to check, once you get here, you can think about solutions. What are some things that are greater than 11.2? So this is x is greater than 5.5. Well, 6 is greater than 5.5, right? So if we want to check this out, we could check x is equal to 6 and make sure it actually is a solution. We go back to the original equation. 3 times 6 plus 4 is less than 5 times 6 minus 7. So is 18 plus 4 less than 30 minus 7? That's 22 is less than 23. Sure enough, it's true. So that makes me feel really good about which way my inequality is facing, and I'm not so worried that I made a mistake. Obviously, we can't check everything. And so that brings us to the second thing we need to know about inequalities. But before we get there, I'm going to show you a different way you could have solved this problem. Another way to solve this problem is to avoid ever getting a negative coefficient. So if I wanted to, instead of subtracting 5x to make the x on the right side disappear, I could cancel out the x on the left side, the x term on the left side, by subtracting 3x. This has the advantage of giving me a positive coefficient on my x. So I don't have to ever divide by that negative. I then would make sure I got rid of this constant so that my x term is isolated on the right side, giving me 11. And then when I divide by 2, I don't have any trouble at all with those negatives and having to flip a sign. The issue now is that when I have this, sometimes students want to rewrite it. Just make sure that your inequality, your alligator, is still eating the bigger term. So this is still the rule that you would get. Any x greater than 11 over 2 is a solution. Now, as you've noticed in all the worksheets, we have different ways of writing these solutions. So writing the solutions is the second piece. Let's start with something a little prettier. Let's try x is greater than 2. Doesn't really matter. But one thing is that this gives us a bunch of different numbers that work, right? If we were to make a list of numbers that are greater than 2, 3, 4, 758, right? We could list numbers forever, and that's only whole numbers, right? I could also do, let's say, 12 over 5. I could keep going, just random things, right? I could do pi. There's all sorts of weird things I could come up with here that come up with this list. So writing out a list of numbers greater than 2 is not going to work. There's an infinite number of solutions there. So what we need to have are a different way to write this. So one way we have is using a number line. So we go to 2, and we have two options as we discussed in class. One option is we can use an open circle. We use the open circle whenever we have a greater than or less than without the equal sign under it. And then if we have the equal sign under it, we use a filled circle to say that we can indeed reach that number. So this saying x is greater than 2 cannot be equal to 2, so we use the open circle, and then we're going to shade the greater than direction, which is everything to the right, right? That's towards 3, towards 4 times 700. So that's one option. The new school way of doing this is to not use the open circles. I don't know why we changed this, but we did. And now the new school way, and the way your book's going to have you do it in the homework, is they use a parenthesis. The reason I don't like this as much is because in order to use the parenthesis, you have to think about which way you're going to shade first. I like having the circle and then using my arrow to tell me which way to shade or to just think about it. But if you do the parenthesis, you do your parenthesis so it catches the shading, and then you'll shade to the right. So that's two ways to write this on the number line. The other thing that we need to be able to write, the other way to write our solutions that I care about, is interval notation. Interval notation, that's terrible handwriting, is written with the lower bound of the values that we can use to the upper bound of the values that we can use. So in this case, what's the smallest possible thing x can either be or get really close to? Well, it's this 2, right? And what's the biggest possible thing x can get to? Well, we shaded the arrow because it goes off forever and ever and ever to what we would call infinity, right? Which we can never truly reach. And then there's one more piece of the interval notation. You're either going to use a parenthesis or a square bracket depending on if we can actually reach this value or not. So the 2, since we have a strictly greater than, we can never really reach that 2. We can go to 2.00001, but never 2. So it gets a parenthesis. Infinity is always going to get a parenthesis. So we'll even put that note here. And that's because if you tell me you've reached infinity, I'm going to tell you add 1 because I've got a number bigger than that. So this is our interval notation for x is greater than 2. And we could go ahead, I'm going to give you guys a chance, do the same work for x is less than or equal to -3. So go ahead, pause the video, try this on your own. All right, so first thing you should have done, throw this on the number line. So start at -3. If you like the circle version, you'd have a filled circle because of the equal to symbol right here. And then you would shade to the left because we have a less than, which less than -3 is anything left of -3. If you do the parenthesis version of this, you'd be doing the same business, except for you'd be using the closed bracket. And I always remember this as a student because it has the equals on the top and bottom and still shading to the left. Now the interval notation here is where things get tricky. Now off to the left side, this isn't infinity, it's negative infinity. And you do want to start with that because that's the smallest possible thing. So it's always left to right. If you have your number line, the interval notation is actually pretty straightforward. So in this case, your negative infinity is the smallest thing, -3 is the biggest. We can still never reach infinity, so it gets a parenthesis. But this time we can reach the -5, so it gets a hard bracket. So hopefully that gives you a little bit of a heads up as to how those solutions to those worksheets in the workbook went. Hope that helps, Sandy.